Hi, Mr. Kane here, and we're going to start looking at our rock cycle. So, here it is, the cycle where things get moved around, different kinds of rocks being made, turn into each other, coming up, going down. What's going on? Let's look into some details. We'll start with our sedimentary rock part of it, and that's this over here. Sedimentary rock involves this sort of part of the cycle here, and we'll look at what's going on there. So, sedimentary rocks, well, things wear out. You know, rocks bounce around the place, get knocked off hills, move around and get made smaller and smaller, and those sedimentary bits, we end up having sand, get moved around by water, wind can blow them, ice can transport them, and they get dropped places. They're always dropped into layers, beds or strata, and they can contain fossils. It's quite a bit of tricky things to have to happen before you get a fossil, but you'll only find fossils in sedimentary rock. Okay? We'll learn why in a moment, but only in sedimentary rock will you find fossils. So, put down into layers, made from bits of rocks that have worn out from somewhere. Okay, so what's going on? We've got this sediment being deposited. So that's going to happen, wind will blow it out of deserts somewhere, glaciers will transport stuff out of mountains, so we might have hot desert areas with wind blowing the sand out of that. It might go out to sea, or it might go somewhere else into a lake. Okay, we've got glaciers grinding away at mountains and then the stuff melting out of it this way, or the glaciers themselves transporting rock on top of them. And then we've got the rivers coming down to estuaries or river deltas here where they come out of the ocean, bringing stuff out of the mountains out to the ocean. So they're transporting stuff, and it can actually be deposited in lakes and stuff on land as well. In the ocean, all the area near the shore will be filled up with sediments that have been washed out from the mountains or blown out off of deserts where it comes from to build up near the shore. But if we go out further into the deep, then it's often mostly made up of what falls down from the surface in the forms of dead animals and skeletons and things like that. Not so much in the way of mud and sand and dirt being blown out there. But sediments get deposited in all these places to make sedimentary rock. So that's what's happening here. We've got rocks being eroded and then transported, sediment being deposited, it's buried and compacted, squashed down into layers, and then we get our sedimentary rock. What's next? Well, we might get metamorphism, changing. So when something morphs, it's a change. So metamorphic rocks, they've been changed because of really, really hot conditions and or huge pressures onto them. So this is our mudstone on the left. So here's our mudstone, and if I crank up the pressure, like that's huge pressure, and heat, we're not heating it to melt it, but we're heating it to make it just soft enough to rearrange itself, and we get a new metamorphic rock type. This can happen in huge areas, okay, especially under mountain chains where two plates, continents are colliding, and we've got this massive area here where there's huge pressure from the plates, and as it's going down it gets quite hot, so we get big regions of metamorphic rocks being formed here. So as we get increasing heat and pressure, mudstone becomes slate, slate will become schist, schist will become gneiss. That's not nice as in N-I-C-E, that's a nice as in, you can only just read that with a G-N-E-I-S-S, nice. Okay. So as the increasing heat and pressure makes those kinds of rocks there. We have a lot of schist in central Otago, and then further southwest in Fiordland we've got gneiss there, one of the hardest rocks you'll find. And we get beautiful banding in it. schist rock has beautiful banding. This is from a fjord wall in Norway, and you can see the beautiful banding on the rocks there as it's been heated and squished and folded and pressurized. Where you've got really hot rocks squeezing and contacting other rocks, you'll get what's called contact metamorphism. So something pokes into it, so we've got hot molten rock squeezing in. So for example, the black rock is the intrusion. Okay, that's something out of a volcano that hasn't reached the surface, it's intruded into limestone, and between the limestone and the hot molten rock we've got a layer of marble. So we've got the volcanic rock here in the middle, the dark stuff. There's this white layer here which is marble, and then the greyer stuff out here is the limestone. So that's contact metamorphism. Another example here, here's a big area of granite dome being pushed up. It's an area of, we'll look into that in a moment, of igneous rock, the other rock type being forced up, and it's contacting mudstone stuff here. So here's unaltered mudstone, but as we go closer and closer to the granite, we go through the different stages here of metamorphism with the mudstone. So that's our metamorphic rock here. We get the deformation and folding and pressure metamorphoses the rock, and we get metamorphic rock being formed. Now if we melt it completely, we get what's called igneous rocks. Anything that comes out of a volcano, molten rock, igneous rock, from the magma under the earth. Now, crystalline rock, and all rocks together, really hard to break. Solid rock, this stuff, really hard stuff. If it's come out of a volcano, we call it extrusive igneous rocks, and it's cooled fast, and we've got smaller crystals. It's like basalt. If it's stayed underground, intrusive igneous rock, it's cooled slowly, and we get large crystals, like granite. So that's what's been happening here. We've had rocks melting, and it's coming up as magma crystallizing, it's coming up as igneous rock. And if it comes out above the ground and we get a lava flow, we've got extrusive igneous rocks. But if it's staying below the ground and cooling here, we've got intrusive igneous rocks. And here's the key to it all: uplift. Okay, without this we wouldn't have these processes. If rocks didn't get lifted up to make the mountains, then we wouldn't have the weathering and erosion to create the sedimentary rocks that we have. If nothing was being uplifted, the world would be flat, because the erosion would have long ago made everything flat. And all this whole process of transportation, deposition, just stop. And scientists think that if all these processes stopped, the rock cycle stopped. It's a very, very slow cycle, like it might take millions of years from one step to the next. But if it stopped, life would stop. We wouldn't have any soils and such from all the weathering and erosion that we would be growing stuff in. So that's the rock cycle, and I hope that has been helpful.